All right, the homework today is the top row only, numbers 2A, B, and C. For 2A, we're just solving for the variables. It says right here, solve for the variables. But in parts B and C, we have to show the triangles are similar before we can solve for the variables. So in parts B and C, there's going to be a little mini proof. So let's first look and see if you remember this relationship with triangles. If A and I are midpoints, so right here and right here are midpoints, well, that's giving us a hint that there's this relationship on the triangles called the mid-segment theorem. So I put it right here in case we don't remember. And if the whole class is like, we don't remember this, we need to practice this, then we'll go over it. But what does the mid-segment theorem say? It says that this middle line, if it is a mid-segment, halfway between each side, then it is parallel to the bottom side, and this line is half of the bottom side. So DE is half of BC. Okay, so we're going to use this relationship to solve for the variables up here. We need the parallels and we need to know about that half rule. Okay, so let's go see what we can figure out from this. So if I know that this is a mid-segment because A and I are midpoints, then I know that these are parallel. And I know that that little green line, the mid-segment, is half of the bottom line. So 153 is half of x. So how do I solve backwards for this? I'm going to multiply both sides by 2. Grab your calculators, and you should get 150, that's 300, that's 306. How's that? So that little line is half of that bottom line. We just solved for x. What would we write as the reason for that? We would write triangle mid-segment theorem. So is that something you remember or something we need to practice? Okay, that's for the x. Now let's do the y. Well, what can I tell from the picture since I have parallel lines? If this is a 74 and these two lines are parallel, couldn't I say that this is also 74 by corresponding angles are equal? Okay, so I can say that by corresponding angles, that one's also a 74. So now I can solve for y. I could say that y, an exterior angle, is equal to the sum of the remote interiors, the 74 plus 20. So this y is equal to the 74 plus 20. So y is equal to 94 degrees, and the reason is exterior angle theorem. Okay, so that's your x, that's your y. These are our two answers for that one. All right, let's go do the mini proof on the next one. So when I'm doing proofs for triangle similarity, I have three options. It could be an AA similarity theorem, always look for two angles. It could be SAS similarity theorem, or it could be SSS similarity theorem. So let's go see what we have in part B. Part B, I only see one angle right here that we could say is equal. And so I'm going to say angle A is congruent to itself. You got it, by the reflexive property. So that's one angle. That means probably we're shooting for this side angle side one with the two other side ratios. So let's look at what we have. We could do AM compared to AO. And that's going to be AM over the full length of the side right here. This is going to be called over AY. And then over here, the full length of this side is going to be AL. So let's go put the numbers that go along with that. So AM is 35 over AY, the full length, this whole thing right here. Do you see how that's 35 plus 10? Or 45. Now let's go to the other side. It's going to be 49 over the full length. 49 plus 14 is 63. So what goes into 35 and 45? We're going to reduce that. What goes into 49 and 63? We're going to reduce that. So 7 goes into 35 5 times. 7 goes into 45 9 times. 7 goes into 49 7 times. 7 goes to 63 9 times. Oops. Sorry, 5 goes into 35 7 times. So do you see how I get the same ratio for both? 7/9. You could have done this whole thing as big over small, and got 9/7 and 9/7. So we did get that the ratios of corresponding sides are equal. They are both 7/9. And so I can say that the triangles are similar. Triangle AMO is similar to triangle AYL by side angle side similarity theorem. So all of that work was for the proof. Now I'm going to go solve a proportion on that triangle. So do you see how there's a little X right here? What color do I want to make this? Let's make it pink. So X on this side, X plus 8, and this side has a 3x minus 2. So we're going to use the bottom side for sure in this. And then you can use either the right or the left to help set up your proportion. So I'm going to say bottom. Actually, let's write this in a different color. Bottom is to side. So that's the whole left side. As other bottom is to other left side. This helps me set up the proportion. So 35 times, I'm now cross multiplying, x plus 8 is equal to 45 times 3x minus 2. Okay, grab a calculator for that. 35 times 8 is 280. 45 times 3 is 135x minus 90. So now I'm going to keep solving this. 35x is on this side, 135 on this side. So let's minus the 35x this way. I'm going to get 280 equals 100x minus 90. Add 90 to both sides. Okay, 270 divided by 100 was 2.7. All right, let's go do the triangle proof on the next one and then solve the proportion as well. So on this one, it looks like I still have one angle and I also have the side. Oh, I can actually use angle on this one. I just saw a little shortcut. Okay, so check this out. Yes, we have the reflexive angle here. We could say angle N is congruent to itself. It's shared in both triangles. What do I mean both triangles? I mean this triangle, we're trying to prove it's similar to the whole triangle. Okay, so that angle is shared for both. So angle N is congruent to itself by the reflexive property. Now, since it has parallel lines right here, we know these are equal. Angle B is congruent to angle NET by corresponding angles are equal. And so I have enough for triangle similarity, 2 angles. AA similarity theorem is enough. So we say triangle BAN is similar to triangle ETN by side angle side. I'm sorry. That was the last one. This one is by AA similarity theorem. So that's my little mini proof for triangle similarity. And since they're similar, now we can solve for x. So they're asking us for the full 2x minus 3, the long side. They gave us a short side of 11. They gave us the other side of 25. And then the whole thing right here would be 25 plus 7, which is 32 for the whole length AN. So here I go setting up my proportion. I'm going to say, I don't know, big side, 2x plus 3 is to small side, 11, as big side, 25 plus 7 is 32, is to small side, 25. Now we're going to multiply. Do you guys know the 11s trick? If you take the 2-digit number that you're multiplying 11 by and split it, and then add those digits, 3 plus 2 is 5, that's what 11 times 32 gives us. Ooh, 11's trick. Okay. So anyways, one side is 352. The other side is 25 times the quantity 2x plus 3. And then we need to distribute. 25 times 2 is 50x. 25 times 3 is 75. Minus 75 from both sides. So 352 minus 75. 277 divided by 50. 5.54. Okay, so our second answer is 5.54 after solving the proportion. How'd you do?